Hey everyone, I'm Alex and I run a small online shop where I build bike parts in my small garage, and over the winter I discovered I have some time left and I would like to build an industrial robot because I don't have any co-workers and I need to leverage automation. But to be honest, it's a bit expensive and therefore I will try to do everything myself, or most of it. And today we're gonna start with the actuators. I decided to go for stepper motors and cycloidal drives because I can mill them out. And yeah, so alright, so the first part was to design the cycloidal drive. Actually it's a whole joint, so it will have the base plate and the arm for joint 1, so the rotating base. And here you can see all the bearings, needle bearings, fasteners and the stepper motor. And now we will assemble it. So basically this is the cycloidal disc and we have a 40:1 reduction, and now we're gonna install the stepper motor. Alright, to get the gearbox to this point I needed 3 iterations. I tested it with around 70 Newton meters. So this motor is rated at 3 Newton meters, so with the 40:1 reduction we should get 120, but obviously because it's 3D printed the efficiency is not very high. But now comes the fun part of milling, and hope you enjoy the chips. Alright, let's assemble all of this. Tolerances seem okay for my machine. And after that, we will come back for another test. So all the bearings are now inserted into the parts and up to a final assembly for the mechanics of the joint. And for a next part, I will machine the cycloidal discs and the center shaft. And if you're interested, leave me a comment or like this video so I will continue to film it. Thank you.